so we're in 6-3. We're finding the least common denominator. And this is something that we've done before, but with numerical fractions or constants. But we haven't done this with our rational expressions now that we have variables involved, right? So first of all, we know that a rational expression can be written in infinitely many forms. Okay, for example, let's take 2/3, right? 2/3 can be written as 4/6. It can be written as 6/9, right? It can be written as 8/12, and so forth and so on, right? We could play that game forever. And the same thing with variable expressions, right? Like if I have x over y, that's the same as 2x over 2y, right? It's also the same as xw over yw, right? So basically you can do whatever you want to a fraction, and we've been dividing by the same thing, but you can also multiply by the same thing on top and bottom, right? That's the same as multiplying by 1, and so that gives you an equivalent fraction, right? Same thing here, like I can multiply by 2 on top and bottom, and that gives me 4 over 6, right? I can multiply by 3 on top and bottom, that gives me 6 over 9. If I multiply 2/3 by 4 on top and bottom, that gives me 8 over 12, right? So they all have the same value, but their appearance is different, right? Now, the reason this is important is because when we add or subtract fractions, we need to have common denominators, right? We need to have identical denominators. So we have to be able to change the denominator in order to make it a common denominator, all right? So we've talked about changing a fraction by reducing. Now we're going to be expanding or building up the denominator at times to make it match so that we can add or subtract fractions, okay? So this 6-3 is getting us ready for 6-4, which is adding or subtracting rational expressions, okay? So let's take a look at a couple examples. So here we're just trying to build an equivalent expression, okay? So number one, we're given 3 equals what over 12, right? So think about what divided by 12 equals 3. And there's a few ways to do this, and you might already know it right off the top of your head. But one thing that I like to do is think about what the denominator is and what did I have to multiply by 1 to make it into 12, right? We had to multiply 12. So if you did that to the bottom to get this denominator, then you have to do the same thing to the top to get the new numerator, right? So 3 times 12 is 36, right? So 36 is the missing number there. Okay, and 36 divided by 12 is 3. We can easily check that. All right, now here we have this one. So what did I do to w to make it into wx? I multiplied by x, right? So I'll do that here. 3 times x is 3x. Okay, and we can check our work, right? 3x divided by wx, the x's would cancel out, and we just end up with 3 over w. All right, and then last but not least here, we're going from 3y cubed in the denominator to 12y to the 8th, right? So 3 times what equals 12 times 4, right? So we have to multiply by 4 on top and bottom. And then how do we get from y cubed to y to the 8th? Well, remember when we multiply bases, we add the exponent. So 3 plus what equals 8? And it'd be 3 plus 5, right? So y to the 3rd times y to the 5th is how we get y to the 8th. So I'm going to put a y to the 5th here. So 2 times 4y to the 5th, that comes out to be 8y to the 5th. All right. So here we have a couple more. This time we have variable expressions in the bottom, right? So this one's a little trickier. So what I would recommend doing is to factor the denominator. So we have 3 is a common factor, and then x minus y. And here we have 6 as a common factor and y minus x. So how would I get from 3 times x minus y to 3 times y minus x? Well, first of all, 3 times 2 equals 6, right? So I have to multiply by 2 and do the same thing on top. And then how do I get from x minus y to y minus x? So they're opposites, right? So that means I would have had to multiply by negative 2. Okay? And so I multiply 7 by negative 2 in the numerator, and I get negative 14. Okay, 7 times negative 2 is negative 14. All right, let's check this one out over here. So here, nothing I can factor on the left side, but on the right side, I have a simple quadratic, right? I have a 1 in front of the x squared. Is not a perfect square, so it's not a perfect square trinomial. So I can put an x here, x here. Looking for numbers we can multiply to get 12 that I can add to get 8. So that would be 6 and 2, right? And remember, this tells us the sign of the bigger number. And because this is positive, that means our signs are the same. So this will also be positive. Okay, so now it's pretty clear. What did I multiply by x plus 2 to get x plus 6 times x plus 2? We multiplied by x plus 6, right? So I'm going to multiply an x plus 6 here on the bottom to get to this. Then I'm going to do the same thing on top, multiply by x plus 6. Don't forget parentheses there. So my result is going to be x minus 2 times x plus 6, right? And you could FOIL that out if you want to, but it's okay to keep it as a factored polynomial as well. All right, so that's how we're just practicing building equivalent expressions, right? And so we're going to do a lot of that in order to add and subtract rational expressions. And when we solve rational expression or rational equations, we're going to do a lot of this as well.